Okay, I'm only on for 3 slides, so we'll make this quick. I just want to thank everybody for showing up today. And welcome to our Getting to Zero presentation by C-Free. The acronym, if you're curious, stands for Carbon Free Residential Everything Electric. And C-Free is a working group of the Lincoln Green Energy Committee. The first session of this series was last week, and we talked about the envelope, and there was a conversation just going on about how well that went. Today, we're going to take a deeper dive into Windows, and that presentation will be put on today by Patrik Muzila from European Architectural Supply. And as you note on this screen, we have more presentations coming for you. We're going to introduce solar. We're going to talk about heat pumps. We've got a session presented by FOMA on the historical home, things to consider if you've got an old home and what you can do to retrofit. We'll be talking about living green and other things that you can do beyond retrofitting your home. And don't forget our electric vehicle show on July 4th. So I'm going to pass this over to Patrik. Patrik is a resident of Lincoln. He has his business in Acton. He is a founder of European Architectural Supply, which is a leading high-efficiency window company. He was an early, and I didn't know this until he sent me his bio, that he was an early internet pioneer, co-founding the web software company Alair Software in 1995, which later became part of Adobe. That's pretty cool. Patrik started EAS while on sabbatical, supervising the construction of his new home in Lincoln and looking for higher performance windows. The woman at Big Meister had a similar story. She retrofitted her home and suddenly her whole career became working with making homes friendly. So with that, Patrik, I'm going to let you take the screen and talk to us about Windows.
All right, let me just share my. All right, I'm a pretty fast-paced presentation giver. So if I'm moving a little too fast, just stop me and ask questions. Feel free to interrupt me as we go through. You know, I got into the window business accidentally, just as we mentioned. I was building my new home in Lincoln and really wasn't happy with the window choices that were out there, and kind of accidentally started this company, you know, needing my windows. And a friend of mine in Weston was looking for windows as well, and kind of one thing led to another, and we're now in the 20th year of operation. So we're becoming a pretty substantial player in the high energy efficiency space. So I can say I have 2 decades of window industry experience at this point. So if you guys attended the last session on building envelope, you know, windows are part of the building envelope, right? And so we kind of know what we have to do with the walls. Windows are just as important. You know, windows are challenging because you know, they need to be translucent, right? So there's only so much we can do with the energy efficiency while still be able to see through these surfaces. You know, the technology has really come a long ways just in the last 10 years to a point where windows can now almost compete with conventionally built framing on energy efficiency. You know, the heat gain or loss through the windows is really a major part of the heating and cooling load of a home. You know, depending on, you know, how your home is constructed, it can be 25 to 30%, sometimes even more if you happen to have leaky windows. Apart from energy efficiency, windows also have a major impact on the occupant comfort, right? They have an impact on sound. They have an impact on natural light and how you feel, you know, in the home, security, and comfort. Even something as simple as being able to read a book next to a very large window of a contemporary home in Lincoln, for instance. There are a couple metrics. So how do we know a window is good? the two major metrics that we look at with a window is the U value and the solar heat gain coefficient. So let me talk about the U value. You guys must have heard about this before, but let me just kind of reiterate it. The U value really measures the resistance of a barrier, in this particular case, a window, at moving energy heat from one side to the other. In this particular case, we're mostly concerned moving the heat during the heating season to the exterior. But this also has an impact, in a cooling season where the heat from the outside is trying to get back to the interior of the building. In northern climates, based on the Energy Star rating, the guidance we have is that a window should have at least a 0.30 U value. In our company, 0.30 U value is not a great U value. We are really thinking about windows at being 0.2 and better. And this is one of the main kind of the distinctions between kind of the North American window market and the European window market. Here in the US, we're still kind of trying to get our windows to kind of below the 0.30 mark. In Europe, almost everybody operates at the 0.20 or better performance mark as well. So when you guys are looking at new windows or the windows that you have right now, U value is one of the metrics that you're looking at. The second metric is a solar heat gain coefficient. Now, this is a measure of the amount of solar radiation that passes through the window and transfers energy into the home. Now, here in New England, during the fall, winter, and spring, solar heat gain is a friend, because this is the additional heat that we're getting into our homes for free from the solar radiation out there. And you have all felt this. You have a room probably in your home with a large southern facing window, and you can physically feel how much energy can come through this window even on a very cold winter day, when the sun is shining just at the right angle and going through this window. Solar heat gain coefficient is an enemy or a problem in August, right? Because that's the month where we're trying to cool our homes, and the solar heat gain that comes through the windows is the additional heat that we're trying to get rid of, trying to cool that space to a comfortable temperature range. And so solar heat gain coefficient is a little bit more of a complicated measure than the U value. The U value is very straightforward. Buy the windows with the lowest U value that you can afford and fits your design. With solar heat gain coefficient, we really want to consider the design of the home, orientation of the home, the amount of glass, amount of shading, for instance. So deciduous oak tree will reduce solar heat gain coefficient in the summer because it's filtering the sunlight that's hitting the building. When those leaves fall down and the sun is coming through those branches and into your room in the winter, that's a pretty good solar heat gain coefficient control device. Trees, right, which we have a lot of here in Lincoln. And so to properly work with solar heat gain coefficient and design it for your windows, this is the area where we start talking to an energy modeler that can look at our building and recommend to us what the solar heat gain coefficient we should be looking for, or whether we should be looking at different sides of the house with different values. So it's a little bit more nuanced, but at least now we know what the second variable means. Let's have a look at how a window is constructed. The part that we look through the glass is pretty straightforward. This is the part that used to be in the past the most vulnerable part of the window for energy transfer, and we have really come a long way. The triple pane glass available today on the market is argon filled and provides energy efficiency, which is currently better than the energy efficiency of the frame of the window. So we have gotten to a point where the glass is so good that the energy efficiency of the glass is better than the frame. And the energy efficiency of the glass in many instances, I believe, is better than some of the old walls we have in Lincoln, right? So even when we have a 2x4 wall with some amount of insulation in it, modern triple pane glass today is already performing better some of these existing envelopes that we have. So the frame is the rest of the window. Frame has two factors of the frame that impact the energy performance. One is the actual energy coming through the frame. So how much of the heat is moving through the frame itself. Windows which are made of metal are particularly punishing. So if you have one of these contemporary homes in Lincoln and you happen to have steel frames or thermally not broken aluminum frames, you can just feel how much energy is coming through it. You're looking at that frame today, and you're probably seeing frost on it. You may be seeing condensation on it, and its surface temperature is probably, somewhere in the 40s and 50s. This is energy that you're losing through the frame of the window. The second part of where frame has a huge impact is frame and sash is where the gaskets are. And this is where a lot of the air tightness comes in. So it's one thing to have a window that is constructed from materials that resist heat transfer. If the window is leaking air through it, meaning the air inside the room that I've spent money heating, through my heating system, and if I lose 5 times the volume of the entire house every hour, essentially you have to be constantly heating the air inside the house. And this is where air tightness becomes really important. And, windows are usually the most serious culprit in getting air leakage in buildings. Separately here in the slide, we have the inert gas mentioned. This is the gas that's in between the panes of the glass. And, we found out that, inert gas is a lot better at resisting heat transfer than regular air. And so nowadays we fill the glass with argon. And the two things we're looking for is one, create sufficient cavity inside the glass for the argon, or 2 cavities in the case of triple pane glass. And the second factor is we want to keep the argon in the glass, right? And this is, an issue of the quality of the glass. How long is the argon going to stay in the glass? How many years is it going to take for the argon to leak out of the cavity, which is a big factor of the quality of the window that we're looking at. Let's talk about triple pane windows versus single pane and double pane windows. The cross-sectional drawing right in here give you an idea of what we're talking about. I'm not going to spend an enormous amount of time here. Single pane windows are a complete disaster in terms of energy performance. It's, on a factor of 10 worse in energy, preventing energy transfer than a triple pane glass. Double pane glass is hopefully what we are mostly seeing in Lincoln homes right now, because, a lot of the windows got replaced with different quality of double pane glass. And triple pane glass is really, the new technology coming in the last, I would say 8 to 10 years. Used to be really unusual, really expensive. It is now becoming mainstream in both residential construction and a requirement, a lot of multi-unit construction in neighborhoods that require stretch code energy requirements. So for instance, you're building an apartment building in Cambridge, you are most probably going to have to use triple pane windows to build that building. And we're seeing that on almost every project that comes up in the last few years. Some of the numbers here, the efficiency of the windows, the single pane to triple pane, you were looking at 50%, in many instances, even greater than that in terms of the energy efficiency. The dollar figure on annual energy savings are a little tricky here. I mean, we see in the slide here, $71 to $500 annual on household energy bills. If you have a Bauhaus contemporary home with a fair amount of glass in it, the windows have just an enormous impact on the economics of heating and cooling of that home. And of course, we have better sound attenuation and safety with the windows, particularly if we have a double pane or triple pane windows. Single pane windows, I was just going to mention that, really quickly, if your home has single pane windows, you should really seriously consider getting rid of them and replacing them with double pane or triple pane windows. There is absolutely no argon insulating gas in there. They're terrible for sound transmission. They are uncomfortable to be near during the fall, winter, and spring months, and they are really expensive to heat the home with. This slide kind of, gives us the answers to, or some of the guidelines to the really difficult questions. Like, how do I know I should spend, the pretty significant resources to replace windows? So the single pane windows kind of make the decision very easy. If you have single pane windows in your home, you should really be looking for a way to replace them. That's like almost given. Windows which have poor airtightness, so are leaky, and you know which these windows are. You walk by a window and you see the draft coming through. This is definitely a candidate for replacement. There are some short-term remedies that you can do in terms of improving the air sealing of windows. There's a lot of people going around with caulking guns, with adhesive tapes. Home Depot has a whole section in the fall on improving airtightness of leaky windows. And this is something that I definitely recommend doing, because it's something you can do right away, something that costs 1% of the cost of replacement of the windows, and something that can have a really huge impact on the air changes per hour. That's the measure that we have in homes. How many times does this home leak the entire volume of the air to the outside? A really high performance home that we're working on the passive house quality has a number of air changes 0.6 ACH 50. These are air changes measured at 50 Pascal pressure differential. A decent code compliant home is between 2 and 3 air changes per hour. Most of the homes in Lincoln are probably leaking 5, 6, 7, 8 air changes per hour. So think about it, like every hour, you kind of have to heat the interior of your home, the volume of the air, probably every 10 to 12 minutes, right? One of the guidelines here on replacement of windows is, of course, larger the windows are in your home, the more you're motivated to do something about them. So if you happen to have a contemporary home, one of the deck homes, right? Homes that have a really large expanses of glass, suddenly, you guys have talked about the building envelope, that glass is a bigger percentage of the envelope of the home. So the more of the glass you have, and the worse that glass is, the more motivated you should be at thinking about replacing the window. Windows which are faulty and they just do not work right. There are two types of faults here. One is like, I really can't open this window. And another one is you maybe had a seal failure in double pane window where the argon is long gone. And the way you know that you got a seal failure in that insulated glass assembly is the windows get milky and they get foggy in the morning. And they become an aesthetic nuisance. That kind of a window has essentially failed in terms of this glass insulation value. And if you have more of those windows in your home, that's again another factor that may motivate you to change the windows. And then another factor that's really important is, I maybe really have to do something about the rest of the envelope of this home. The siding is in such a tough shape. Maybe have a lot of overhanging trees, and there's just a much more accelerated degradation of the siding or shingles on the outside of my home. Anytime you're doing major restoration work on the outside of your home, anytime you're changing your cladding, your siding, your shingles, your vinyl siding, whatever it may be, anytime you're reworking the envelope of your home, that is the right time to tackle windows as well, because to do windows while you're doing that work will save you an enormous amount of money in the overall cost of the project. And often replacing windows on a home that just had like new siding put on 4 years ago and it's all freshly painted, it's one of the factors discouraging you from maybe working with the windows, because you know that you're going to have to disturb the trim or some of the siding around it. So if your house is scheduled to have siding dealt with in the next few years, right away you should think about windows alongside with that, with exterior cladding work. Choosing your windows. So the federal government has given us some guidelines on how to choose windows. So we looked at the U value and the solar heat gain coefficient. And so the Department of Energy came with the energy efficiency standard through the Energy Star program. Now, this is a prescriptive set of guidelines which divides the country into a series of regions, northern, northern central, south central, and southern. And they essentially give homeowners guidance on which benchmarks you should really be hitting with the U value and the solar heat gain coefficient. Now, here in New England, it's pretty straightforward. U factor as low as possible. They're asking us to go below 0.30. And solar heat gain coefficient, we actually benefit from relatively high solar heat gain coefficient. So they're not giving us a guidance on bringing our solar coefficient down. If you are in Texas or Florida, the solar heat gain coefficient is a huge factor, because in those climates, you worry about your cooling cost more than your heating cost. And so in those climates, they actually ask you to keep the solar heat gain coefficient under 0.30 or 0.27, and they allow you an almost criminal U value of 0.60, which it's kind of getting difficult to buy a window with this kind of performance. But it's still on the Energy Star guidance sheet. We in our company work on a lot of projects which are really moving far beyond the Energy Star guidelines. If you would show Energy Star guidelines to a European construction professional, they would be really surprised how unambitious some of these values are. When we're building new homes, when we're doing major remodels to homes or energy retrofits of homes, we are really looking for kind of way beyond Energy Star. Most of our customers use windows which have U factors between 0.13 and 0.20. That is the kind of window that I think we're going to be using in North America in the 21st century. And these windows enable us to retrofit homes to a point where we no longer need like conventional heating systems. These homes are getting rid of their boilers and they're using, all electric Mitsubishi mini splits or something like that to cool and heat the homes. But it's, I have to mention Energy Star because it is still the primary guidance for code compliance. It's a primary guidance for subsidies in the United States as well. So it's just something we have to keep an eye on. But I would hope that people would look further beyond Energy Star. Energy Star is getting revised this year as well, so they're tightening some of these performance metrics, but just a small decimal points. But we're still kind of running about a decade behind of what the Europeans think we should be prescribing. I'll mention incentives for window replacements. MassSafe has a number of energy saving programs. They change all the time. So I always encourage you to go to the website and look at what the current incentives are. They give incentives of $75 per window. We're replacing a single pane window with a window that's at least Energy Star compliant. And they also offer 0 interest 7-year loans, which are a really tangible help when making a major investment replacing windows. The other incentive that I haven't mentioned is there are also tax credits available from the federal government for energy improvements. Again, they change quite a bit. I know that they changed with the new act that was enacted last year, which made huge changes to electric vehicles, tax credits for energy efficiency improvements. So I would consult an expert hopefully a tax advisor to see what those options are. But some of them are really substantial. You're looking at 30% tax credits for some of these improvements, which is a major saving. Steps for replacing window. I mean, let's talk about this just a little bit. What is involved in, getting windows in and out of the building? Working with a good installer is obviously really important. Buying a good window is pretty straightforward. We know we have the metrics. Hopefully, based on the parameters of the windows, we can pick a vendor that sells a high quality window. Installing that window properly into the opening and sealing it to the building is a really important task. My recommendation is always review your installers and ask them what kind of work they've been involved with. If you're working with a window installer that has worked on net zero projects, deep energy retrofits, passive house projects, if you're hearing those words, you're going to know that this installer has experience with what I would call the 21st century way of installing a window. It's not just about anchoring the window into the opening, but properly treating the shim cavity around the window, properly air sealing the window to whatever might be available in the wall assembly, and making sure that you don't want to put an airtight window into the opening and have all the air blowing right through that shim cavity. Make a decision and sign the contracts. Read the reviews, and mostly ask them about the project they worked on. Some of the other things to keep in mind. So I already mentioned that the proper installation is crucial when installing a high quality window. We talked a little bit about the siding and exterior cladding work. Absolutely, doing the windows together with the siding is those are the two jobs you want to be doing together. Don't sacrifice window quality. The amazing thing is that what I see in the marketplace, especially on the commercial side, but it comes to residential side as well, paying a lot of money for a window does not necessarily mean you're getting a really high quality window in terms of energy performance. It doesn't make sense, right? But there's a lot of pretty expensive windows, which in my opinion, do not have the energy performance that they should have with that kind of a price tag. And so every time you're looking at a new window, look at those two metrics. The U value will speak for itself. If you're dealing with a vendor that's a U value in the 0.2 or better range, you're looking at a good window. Air infiltration is another value that you see, the sticker that comes with the windows. The lower the air infiltration value, the tighter the window is. Style of a window has an impact on this as well. Casement windows are typically more airtight than double hung windows, which is just the nature of the construction of it. But have a look at the metrics of the window, and it will guide you. You don't need to be perfect. Replace what's faulty on its improvement. That's really, really true. I mean, there is maybe a side of the house where the windows are of a decent quality and you just resided that portion of your house 8 years ago and everything is painted and caulk and it's a pretty good airtight and watertight condition. But you have a window on another side of the house that's a real leaky, unpleasant window. Even replacing a single window can have a difference. When we're talking about airtightness, you might have one window or one really bad sliding door that might be responsible for 80% of your airtightness problems with your windows, right? So even replacing one particularly bad or just a handful of windows might have a tangible impact on definitely energy efficiency, your energy costs, and comfort in that room. In summary, I mean, it's pretty straightforward. Windows are an important part of the envelope. We want to be looking at windows which are Energy Star compliant or better. It's getting kind of difficult to buy a window which is not Energy Star compliant. So I think that's becoming less of an issue. The U value is the one metric you really want to be paying attention to. And a solar heat gain coefficient is a little easy for us here in the northern climates. A high energy solar heat gain coefficient in the 0.4 and up range is perfectly fine for your home. The only time you want to pay attention to it and maybe lower it if you have so much glass in your building that you're concerned that solar heat gain may be a problem for you in August. And that's where you hire an energy modeler to look at your envelope, look at the angle of the sun, the trees, all the geometry that's involved in it. Look for a good opportunity to replace your windows. We spoke about, kind of the tandem work with the cladding. Work with good installers, people who have experience with, and especially people who have worked on high energy efficiency projects. So those words that you're looking for, oh yeah, I worked on a passive house, I worked for a net zero home, I worked on a deep energy retrofit. If you have window installers that have worked on those kind of projects, they have experience with working with good airtight installation techniques. Keep in mind your own needs and upgrade what you can or what you need or what you can afford, right? So that's the end of my presentation. You guys want to ask questions?
Hi, thank you so much for this. This was really helpful. You talked about doing exterior rehab at the same time. Just curious, does that for sequencing though, do you do the windows first and then the exterior rehab, or I would think so, or vice versa?
Correct. So typically the way this works, so we've worked on a lot of deep energy retrofits. Now there are two ways that you can do the exterior work. One is that you are just replacing the surface that you have on the outside of your home, that the siding is so rough that needs to be replaced. And so typically you strip all the siding of the home, then do the energy, then do the window replacement, right? So you can kind of tape the windows to the exposed sheathing that's behind the siding. This is also times where you can apply new membranes for better weatherproofing. And so we have a lot of new materials that we can apply underneath our siding that makes our buildings far more water resistant. These are also membranes that can air tighten your home. So in deep energy retrofits, they apply a membrane to the outside of the home, they tape the windows to it, and suddenly all the leaky walls that you used to have, everything becomes airtight. And so this is what's often called deep energy retrofit, where they take the siding off, they put a membrane on the outside of the home, they tape it to the new windows. And the next step that they take, and this is where it becomes a deep energy retrofit, is they actually add the insulation to the outside of the home, and then they apply the siding. Obviously adding insulation to interiors of walls is really messy. You have to make holes in the walls or sheetrock, or sometimes they strip all the sheetrock. Those are the really complicated and messy way of doing it. If you want to continue living in your home and you don't want to disturb all those interior finishes, you have beautiful moldings, budget doesn't allow for all of that. The deep energy retrofits essentially do all the improvements of your envelope on the outside. You probably heard about this during your last presentation. Siding gets stripped off, windows get put in, membrane gets applied and sealed to the windows, and then they add 2 inches, 3 inches, 4 inches of rigid insulation on the outside, and then they reclad your home. So your walls all become just a little fatter on the outside, right? Your siding kind of moves out 4 inches to the outside, and you work with the trim to do that. But you can take your home, your entire envelope, not just the windows, from just a really poor performance envelope to an envelope that will outcompete brand new typical builder code compliant homes across the street. Because the air tightness, insulation, and the windows, once they're all tight together, have a huge impact on the energy efficiency.
Okay. And do you know vendors that do that? It sounds like you should get someone to do both of those things at the same time.
Absolutely.
Yeah.
Yep. So your presenter during the last presentation, they specialize in that kind of work. So I've seen them do, we've supplied windows to them for deep energy retrofit. The last one I remember was in Waltham, and this is exactly what they did. And they can take a home that's been built 70 years ago and bring that envelope to a point where it's 60-70% more efficient than a brand new home across the street. It's incredible.
Thanks.
I have a question. I have a house that has a lot of fixed windows. They're usually, many of them are ganged up with some operable awnings underneath, but the frames that were, this house was constructed in the 60s, and the frames are integral to the stud system. So the windows may only come, 30 inches from the floor, but the frames go all the way down and connect into the studs. So I'm interested in replacing the single frames with a triple pane of glass just by taking out the glass and putting in new glass.
Correct. So this is one of the options you have. Go ahead. I interrupt you.
Yeah, anyway, so I assume that's, fairly easy to do, but I don't know about suppliers that will just give you triple pane glass.
So we are one of those suppliers.
Mhm.
So we have worked on projects here in Lincoln where we only supplied gas. It is, believe it or not, the least expensive way to upgrade your windows, because you're technically not buying windows, you're only buying glass, and glass is relatively inexpensive. The most expensive part of this job is the carpentry work to take the old glass out, bring the new glass in, change the glazing stop, and integrate it in. But in many instances, such as the deck houses in Lincoln, this may actually be the ideal retrofit technique.
I've recently been looking at replacing some failed thermal pane in and that are in aluminum windows that don't have a thermal stop involved, old aluminum windows. And I have been in touch with a company called FiberTech in Canada. Do you have any experience with their windows?
I'm not familiar with FiberTech.
Okay.
But Canada is a little ahead of us in terms of energy efficient windows, just by the nature of the temperatures that they're dealing with up there.
Yeah, they have about 26 different options for where to put the e-coating and the argon or no argon. Or, anyway, it's a pretty impressive list of possibilities.
Roy Harvey asked the question, does EAS work directly with the homeowner or through a contractor?
We work both with homeowners directly, we work through contractors, and we work through architects. So there's these three audiences we have. Energy efficient homes, it's interesting, is these projects often have a really strong involvement from the homeowner. I mean, look at my case study. Like, I accidentally started this business, like building my home and being really involved. We have a lot of homeowners who come to our showroom. They kind of like drag their builders in and say, this is how we should be building. This is the kind of window they're going to put in. And, builders are often kind of grumpy about that because it's like, oh, I can't buy that in my local lumber yard. Like, how am I putting it in? Once they do this once, want to use a high efficiency windows and install it in a really airtight manner, it's really difficult to go back to the old way of installing windows and installing, less efficient windows. So the answer is yes, we work directly with homeowners as well. Okay. A lot.
Laura Olson asks, do triple pane windows need storms and screens? I think maybe she means, do they have them included?
So you should not need storm windows, right? Storm windows, which is that one sheet of glass that we just kind of bolt on to the existing window, were invented for two purposes. One, for waterproofing, because, windows which are not airtight are typically also not watertight, right? So we created storm windows just to create an additional barrier for the splash of water so the water doesn't come in. And we also added it in, kind of hoping it's going to improve the energy performance as well, because we have an additional air cavity between the storm window and the window itself. This cavity is filled with air and it's very leaky. So the storm windows actually don't have a really great effect on the U value of the entire assembly. Most of storm windows and storm doors were more of an issue of water infiltration. With a modern window, you do not need storm panels. With insect screens, of course you need insect screens, because if you want to open your window, we have a lot of bugs here in Massachusetts. So insect screens, and having a vendor kind of have a good insect screen solution for that is important. What are you looking for in insect screens? You want to make sure the insect screen is well constructed and well anchored to the window, so it doesn't blow off during the nor'easter, right? So insect screens are slowly getting a little better. We do all of our insect screens as an extruded aluminum frame, so the insect screens is really rigid and just doesn't fall off the window. Here in North America, we're trying to save money so badly. We make insect screens from really thin aluminum that's rolled into the shape. And so the insect screens are, really wiggly, and, you often find them on the lawn after a windstorm, right? Insect screens are a big challenge. I'll speak about this real quick for big openings, right? So if you have, again, a big floor to ceiling glass home and you have big sliding doors, those are the really challenging openings to put insect screens on, and we try our best to find insect screens for 13-foot openings for our sliders. We do a lot of really large sliding doors, and there are also some retractable screen options that we now work with. But you're right, screens are really important. People want to open up their windows in the spring, in the fall, sometime in the summer.
Go ahead, Nancy.
Oh, yeah. Is there a good place for recycling? These old failed thermopane windows and aluminum frames, the glass in the frame?
Yes. Glass should be really easy to recycle. I do not know what the policy of the Lincoln transfer station is, but they should be able to accept shards of glass in their glass recycling bins. I really don't know what their policy is.
Well, I think that because glass can be fluxed with lead, the glass recycling is just for glass that's used for beverages and couldn't leach lead. So I think that's why you normally can't put window glass in the normal glass recycling.
I was not familiar with that. So it's a lead from the glazing or from the paint? Where does the lead come from?
Lead is a flux for silica. Sodium is a flux for silica. In drinking glasses, lead is not normally used as a flux for baked glass making, but in windows, it could well have been.
I actually don't have a good answer for that.
Okay.
Yeah. In our European markets, a lot of our windows come from Europe, and Germany requires recycling of windows during window replacement. And in fact, the windows that we make that come from German components have recycled component in the windows, in our UPVC windows, for instance. And so the new windows that we're supplying today to our customers have in them recycled PVC content from a window from 30 years ago that gets recycled in Europe, separated from the glass, shredded, and then brought back into the PVC material. I was researching this for a customer of ours who was really interested in this, and they were writing an article on it. And I was wondering if this recycling of windows in Europe was mostly like a marketing gimmick. I found out that the numbers were like staggering. We're talking about millions and millions of windows and millions of pounds of material that get recycled in Europe.
Okay, well, I'll send it off to Germany.
Jane Herlocker asks, and you sort of answered this already, but are there storm windows with double or triple panes?
So I am really unfamiliar with storm windows. I have not seen a double pane storm window. typical storm window is a single sheet of glass that's just, screwed onto the old window frame.
John asks, which manufacturer do you recommend?
Am I okay mentioning manufacturers in the presentation? I just want to make sure. So I will talk. So the reason why my company exists, we import windows from Europe. And the main reason why we can do business is because the North American window manufacturers are not doing their jobs right. They are starting to pay attention to this, but it's a really, really slow process. So we bring 5 different brands of European windows to the market here. Some of the brands you might have heard, some of them are just completely foreign to you. We bring Schuko aluminum and PVC windows, Macrowin wood windows, Aluprof aluminum windows, Salamander PVC windows as well. Here in North America, we are starting to have more and more options for high energy efficient windows. So the two things are happening. The window manufacturers are starting to put triple pane glass into their window assemblies, but they are really challenged by the geometry of the sash that they have, because the sash of a conventional double hung window is really not deep enough to put a proper triple pane glass assembly. Now, is this ultra slim triple pane better than the double pane? Yes, it is. It can bring your window from a 0.30 U value to, 0.24 or 22. I commend them for that. That's still better than not doing anything at all. Some of the best brands here in North America, Marvin has been exploring different options for making a better window. So they probably have one of the best offerings here. Colby is another brand. Pella is kind of trying to catch up. Anderson is trying to get there. I'm not very familiar with the performance specs on some of their new triple pane windows. They're relatively recent arrivals, but everybody's moving in the right direction. Again, each manufacturer sells many different grades of windows. So when you look at Anderson, you have like the 400 series, the 300 series, 200 series. Everybody's trying to create window at different price point and maximize the profit they can get from a high-end customer. So that's where knowing those variables and asking those questions, hey, what is the view value of this window, right? What is the air tightness of this particular window? Because Anderson can make you a much better window with, let's say, the 400 series versus with another series. And sometimes they might have a really affordable window that's maybe in the vinyl UPVC category that happens to have really good performance metrics. So sometimes, like, you remember what I said, paying a lot of money for windows does not mean you're getting a really energy efficient windows. Pay attention to those metrics.
Hi there. I wanted to ask a question. We have a mid-century modern house with a lot of single pane glass, very, very large panes of glass. What would you recommend? It probably covers 1/3 to 1/2 of our entire envelope. And I'm wondering about the cost of getting these huge panes, which I assume have to be custom made, and also whether the wooden structure that holds the window could handle a thicker and heavier window, whether we'd have to reconstruct the entire house.
Okay. So the good news is your home, you remember we're going through the checklist of what are the factors that motivate us to change the windows. You seem to be hitting like a lot of the checkboxes right there. The fact that you have these large expanses of windows, you probably have some walls where it's mostly windows and not a lot of siding. So even that, the decision, like, do I have to do siding windows? It doesn't really matter because maybe your glass is going floor to ceiling. So you change the window, you fix the trim, and you're done with the wall, right? So you definitely are a candidate for window replacement. Do not worry about the custom glass part of it. So one thing that makes our window business unique is that, we buy windows in Europe, and in Europe, there's no standard sizes. You remember, things are masonry opening. So every window project is a custom window project, which means that custom windows do not cost extra. They're just, just nobody has warehouses full of windows like we have over here. Everything is made to order. And so custom glass assemblies or window assemblies are not a problem. You need an extra ½ an inch for this opening. It's just ½ an inch of extra glass in there, right? It doesn't really cost more than that to make. And some of the conversation we had earlier, am I going to be replacing it with glass and window frame, or am I doing only a glass pane replacement, meaning I'm retrofitting these assemblies? Your question about weight of the windows, weight should not be a concern for you at all. Your wall assembly where that glass sits, whether it can handle 1 pane of glass or three panes of glass, the downward pressure, what we call the dead load, is not an issue. The load that's really most concerning to us is the wind load, right? Our buildings have to, survive that Category 3 hurricane that's eventually going to come here, right? And so the horizontal loads are far more concerning to us. And a triple pane glass assembly is typically going to be much stronger than a single pane.
Thank you.
So do your thicker windows fit into a regular home, a non-passive home with the thinner walls?
Yes, so the windows that we make are actually shallower in their jambs than North American windows. So you can install them in a 2x4 construction, 2x6 construction. Most wall assemblies are not going to have a problem depth-wise.
Okay. Deborah asked a question. She lives in a condominium and she doesn't have any control over the envelope of the house, and it's not very good. She does have control over the windows. Would it pay to upgrade the window even though her walls are not very good?
So the answer to that is that question, what is in that window opening right now? How bad or good is the window that's in there? If that window is single pane, it's almost a no-brainer, right? If that window is a double pane and the argon is still in there and it's a pretty decent performance, you have to make the economic calculation for that. If it's a double pane window and the argon has kind of leaked and the seal is already failed, you see fogging inside the glass, which is unsightly, and the windows are leaky, they're like uncomfortable to sit next to, again, that window is probably a candidate for replacement. I'll tell you just a little bit of case study. We are replacing windows in the Jamaica Way Tower. I don't know if you're familiar with it. It's a really unusual building in next to the hospital district there on the Greenway. It's 20 stories tall, so it's like really visible from that neighborhood. And these are condominiums owned by each unit is owned by an owner. And we presented to we had a customer that we had a person who lived in the building, and they were involved in energy efficient kind of architectural industry, and they were like, you guys have to come in here and present to the condominium board because I think we should be putting these kind of windows into our building. And so we came in, we presented, they approved us, and now the homeowners are individually replacing the windows. We do about 10-15 apartments a year. So by now we probably have maybe 20% of this building replaced. We are going from aluminum single pane windows, which today might have frost on them, might have water dripping right off of them, right? We're putting in new, people can choose double pane or triple pane windows. Majority of the windows we put in a triple pane, thank God. When we do an infrared camera temperature measurement of the surface of the glass, or you do one of those thermal images, the surface of the glass is warmer than the surface of drywall in the bedroom. That window is more efficient than the walls in that apartment building. It has a huge impact on occupant comfort. In their living rooms, they have like wall-to-wall glass windows and patio doors that go into the balconies. And they can now sit next to these windows like on the coldest day of the year and feel comfortable. The biggest factor, though, that nobody anticipated at all, this apartment building is right next to the pathway for the ambulance coming into the hospital district, right? We have the Brigham and Women's, all the hospitals are right over there. Every single ambulance could be heard by everybody in this building. We put the new windows in and they no longer hear the ambulances. It's probably a bigger improvement for them than even the energy efficiency. So it's there are all these unanticipated positive side effects of putting high energy efficient windows, and the sound attenuation in this particular case comes out of the air tightness of the windows. Windows that tend to be leaky for air, they also leak sound.
Stephen S., you mentioned the shim channel and the replacement window perimeter. SIGCO will invalidate a warranty with some fillers like standard window caulking, and double hungs can get tight with some of the fillers. What product do you recommend to fill these cavities? And also, which house wrap do you like?
Okay. Good. So these are very technical questions. So let's dive into them. So just a quick background for everybody on the presentation. We're putting a window in. We cannot make the window tight to the opening that we have. There's always a gap in between. Some of the openings they're not perfectly plumb. And so anytime we're replacing a window, we look at what is the rough opening, and then we're putting the window in with some kind of shim space allowances. We have a rough opening that's 36-inch wide. We're going to leave half an inch on each side to make sure we can fit that window in, and that's called the shim cavity. So when we put the window in, we now have to seal this shim cavity, because if we don't seal it, doesn't matter. We have airtight window if air is blowing right through that cavity. So when the two things that we need to do with this cavity, we want to make it airtight and watertight, make sure no air or water is getting into this cavity, and then we want to infill it with material that insulates it. Now, here is the problem with a lot of North American windows. North American windows are so incredibly weak in their construction. Their jambs are so thin and flimsy that when they came in and spray foamed those cavities, the spray foam expanded and it moved the frames just a little bit to a point where you had a brand new window, you couldn't open it, right? That is typically not a problem with our windows. The European windows have so much stronger frame assemblies that this is really not an issue. The only guidance you have to go to your installer is to use a low expansion foam in that cavity. So the spray cans that you can see them at Home Depot, the red version of it is the regular spray foam. That's maybe want to spray that around a pipe opening somewhere so that air doesn't leak through. And then they have the blue cans, and blue cans are the low expansion foam. It's a foam that's formulated just slightly different, and the window foam just expands a lot less, so you have less of an issue with the windows. If a window vendor tells you like don't even use the low expansion foam, do not buy their window. It's a really flimsy frame. I was not familiar with any kind of caulking requirements that you mentioned in the question as well, but window manufacturers come with really strange requirements in their warranties, essentially in an attempt to shield themselves from responsibility for typically a poorly constructed windows. And the craziest thing about it is the lowest quality windows typically carry lifetime warranty. And warranty is only as good as is this company still in business. I mean, every window has a finite kind of warranty period to it. Europeans that sell us windows and we bring here to the United States are so stringent about their warranty interpretation. They don't have any caveats or fine print in there. That they give us windows with 5-year warranties. Sometimes we can stretch it out to 10 years, but we actually have to explain to the customers, even though you're buying a really good window from us, factories really take it seriously and they give us a 5-year warranty for it. Most of our windows are designed for, lifespan of 40+ years easily. But here in North America, the lower quality the window is, the bigger warranty headline it has at the top. So And a lot of this fine print is essentially the warranty is worthless when you create so many little exclusions to the warranty itself. It's a limited lifetime warranty, right?
I think you answered Ken Hurd's question, which was what the life expectancy of the windows are. He asks also, do the European manufacturers use finger joined wood materials in their sills?
Okay. So finger joining is a technique specifically with wood windows. Our wood windows, so we make wood windows and wood aluminum clad windows. The wood windows are wood inside, wood outside, and aluminum clad windows are wood on the inside and aluminum cladding on the outside. The wood aluminum clad window should be maintenance free. It's that window you shouldn't have to repaint. The aluminum cladding should last for the lifespan of the window. The wood portion of the window, how that piece of wood is made is really important. So a high quality window today is made from multiple layers of wood, which are oriented in a way that when you glue them together, they give you a very stable sandwich of the wood. Now, to build this sandwich, window manufacturers often use finger jointed, shorter boards of profiles. We offer the finger jointed version of the windows as well, but we primarily sell the non-finger jointed version. One, it's an aesthetic that we are sensitive about. Two, a lot of our windows have natural finishes, meaning, there's a natural stain on the inside and the finger joints are just visible. And we are somewhat concerned about long-term durability of finger joints, finger joints coming through even a painted window surface. Finger jointed window from our company saves you about 5% of the cost. So we are not particularly keen on making that 5% savings and deal with kind of the finger jointed issues. We have had a few projects where the homeowner maybe made a decision to go towards the finger jointed profile. A lot of European vendors claim that the finger jointed assembly is more stable than the non-finger jointed one. We have not seen any evidence of it. We think that a solid wood multi-ply laminated design is plenty stable. We haven't had any problems with major warpage issues or anything like that. So, so I have a personal bias kind of away from finger jointed profiles, if possible.
I have a question from Sarah Mattis. She has a 1978 sliding doors, and she replaced one of them in the 2000s, early 2000s, and was very unhappy with the amount of sun she lost. And you've already talked about the solar heat gain, but she was told that she had to put in these windows that blocked a lot of the solar heat gain. Do your windows now have, will let in the maximum amount of light so that she has her old solar heat gain from 1978?
So I am guessing what happened in this particular case. Every window has the frame and the sash that kind of compose the part of the window we cannot see through. So we're looking through the glass, but on the edges we have the sash and we have the frames right in there. Often when you change a design of a window, this home maybe had some ultra slim metal frames for the sliding sashes. They were probably, had energy efficiency issues with them, condensation issues, frost issues with them, operability issues. But the new unit came in, the new slider came in, and the slider had maybe it was a wooden sash or some other kind of sash, which suddenly the amount of glass, the width and the height of glass got narrowed down by the change in the frame profile. That is an unfortunate side effect of changing a window type or a technology type. A lot of our windows are guilty of the same thing, because when we build very large sliders, for instance, we have a decent amount of material on the sash itself that would rob you a few inches of the glass relative to what you used to have. We have some new products right now, which for sliders, they're called these panorama sliders. And you might have seen them in architectural literature, but it's all glass, no frame. So we have a slider where in the middle where the slider moves, there is only 3/4 of an inch of aluminum. The slider is almost entirely glass. And you remember how I mentioned to you glass nowadays, like our triple pane glass is more efficient than our frame. The windows are actually really energy efficient in terms of the thermal transfer through the frame, because you have almost no frame. The main problem with those is they are not lift slide doors. I'm sorry, I'm going to technical issues here. They use brush gaskets for air sealing. So air tightness of these doors is maybe not as good as our lift slide doors, which sit on the gaskets and lift up. And so you're making some of these design compromises. Am I going to lose, 2 inches of glass on the slider, but my energy performance is going to go 10x in some instances? Or is the view the absolutely most important aspect to me? And at that point, I'm going to be looking for a product that has really thin frames, but maybe gives me the most triple pane glass in it, like this panorama doors that I'm describing for you.
Great. I just wanted to confirm for Ken Hurd, your Windows life expectancy is about 40 years?
At least.
At least, okay.
At least.
Um,
I will give you guys a quick glance on the windows I was talking about. You guys can still see my screen, right?
yes.
So here we are looking at a window. You see the cross section? Maybe I should go a little smaller. There's a cross section right there. And let me just have a look at the portfolio here. Okay. So you can see this image right here. Everything is glass, and you just have a tiny little frame right in there. So we have some new products that can give us energy efficiency and maximize the glass as well.
Ken Hurd also asked what your lead time is these days for getting windows in.
So it's amazing because we used to be one of the slower vendors. Like we would make the windows relatively fast, but we had to travel across the ocean for about 4 weeks. We are currently one of the fastest custom window manufacturers in North America, because a lot of the other North American brands have gotten so backed up. So I hear that like Marvin windows can be 25-week lead time, and we're delivering windows at 12 to 14 weeks. So we're kind of in a really unique period right now where we, even though we come from far away, can make windows faster than a lot of the North American competitors. Yeah, it's amazing.
And then Jane Herlocker asked, how thick are the windows, a triple pane window?
Thickness of the glass. So the thickness of the glass is 1 3/4 inches typically. So it's a pretty substantial glass assembly. Why don't I have a sample here of this is one of our older designs. You can get a sense. I'm going to put my finger on it. A typical triple pane Anderson window or a Pella window is they put the glass in between these two panes right here. So it's about half the thickness of the glass, even for the new triple pane window assemblies.
I think we've kind of passed our hour. Patrik, that was a fabulous presentation on Windows. I really appreciate your time and all the information. We can certainly pass questions back to you or give people access to you if there are more questions following this presentation. I want to thank everybody for your attendance today, and I hope you took away from the presentation as much as I did. Thank you very much.